In this lesson, we are solving systems of linear equations by using the method of substitution. Our objectives that we can solve the system by using substitution. Let's review. A system of equations. What is the solution? The solution is the point of intersection when we are graphing. At that point of intersection, that is the point that will be true for both equations. What if there is no solution? Then we have parallel lines. And that means they have no points in common, they do not intersect, there would be no solution. What is happening when there are infinitely many solutions? Then we have the same line. Let's review solving by graphing. So in our first equation, we have y equals 2/3 x minus 5. We start by graphing the y-intercept. The y-intercept is at the point 0, -5. And we have our slope being at 2/3 or 2/3. So on our graph, we'll start by putting in the y-intercept, which is at -5. And then we'll use our slope to find our remaining points. We're going to go up 2 and over 3 and continue up 2 and over 3 and draw in our line. Then we're going to label that line as y equals 2/3 x minus 5. Now we'll graph our other line so that we can find our point of intersection. Y equals -2x plus 2. Our y-intercept is at the point 0, 2, and our slope is at -2. So we'll put a point at 0, +2, and use our slope to find our remaining points. Down 2 over 1, down 2 over 1, and then we will draw in our line. Let's label that as y equals -2x plus 2. But I hope you can see that there might be an issue with this because our two lines are crossing partway through a box, which means that our answer, our solution, contains fractions or decimals. And the problem with that is that we may come up with, in a class of 20 people, 20 different answers because we're estimating. So there has to be another way that we can solve this system to find an exact answer. And that's where we now are going to use solving systems by substitution. In this case, we are going to replace one expression with another. You have to have at least one variable isolated in order to do this. Let's take a look. In our first example, solving by substitution, we know that y is equal to the expression 2x. So we're simply going to take the 2x and we're going to replace the y value in the second equation. So we have 7x minus, instead of y, we're going to replace y with the value 2x is equal to 15. What that does is gives us an equation that contains only one variable, and we can solve it. 7x minus 2x is 5x, and that equals 15. We finish solving by dividing by 5, and we know that x is equal to 3, which is the first part of the ordered pair of our solution to our system. To find the y value, we simply substitute the 3 into our first equation. So y equals 2 times 3. In other words, y is equal to 6. That is the point of intersection on the coordinate plane that is the solution to our system. It would be where the two lines cross But instead of graphing, we can solve algebraically by using substitution. We can check our answer by plugging the 3 into this equation. 7 times 3 is 21, and 21 minus y, the value 6, is equal to 15. That is the solution to our system. Let's try another example. We want to find an equation that has one variable by itself. That happens to be our second equation. This expression then is the same as y. So we are going to substitute that expression into the first equation. We now rewrite that first equation. We have 3x minus, and I'm going to use parentheses as I put in my new expression, 2x plus 8, which replaces my y, equals 17. Our goal now is to have an equation that is in one variable. Then we solve. 3x, let's distribute that negative or minus sign, so minus negative 2x gives me plus 2x, and then I'll have a minus 8, and that equals 17. 2x plus 3x is 5x, minus 8 equals 17. I'm going to add 8 to both sides to finish solving for x. So I have 5x is equal to 25, and when I divide both sides by 5, x is equal to 5, which is the first part of my solution to my system. Now I'm going to take the 5 and I'm going to substitute it into this equation for my x value. So I have y equals negative 2 times 5 plus 8. So y is equal to negative 10 plus 8, which means y is equal to negative 2. That will be the other part of my coordinate, which is the point that is the solution to our system. It doesn't matter which of the two equations that you substitute the x value into, but my suggestion is to put it into the equation that will be the easiest mathematically and the quickest for you to solve. Let's take a look at another example. Now, both of these equations are solved for y. Not a problem. I'm just going to take this expression, which is y, and substitute it into the other equation. So I will rewrite and have 2x plus 1 instead of y equals x plus 3. Now we have an equation that is in one variable. We simply just need to get the x's onto the same side. So I'm going to subtract x from both sides. X plus 1 is equal to 3. And I'm going to subtract 1 from both sides, so x is equal to 2. That is the first part of my ordered pair to the solution to my system. Now it doesn't matter which one we're going to plug it into. I'm just going to pick the top. So y equals, I'm going to substitute the x value into my top equation to find my y value. 2 times 2 is 4 plus 1, so y is equal to 5. And that is the other part of my ordered pair, which is the solution to my system. I can take that and plug it into my second equation just to be sure. 2 plus 3 is equal to 5. It works, and it's the solution to my system. Let's take a look at this example. Again, what I'm looking for is that one of these equations has the variable by itself. The second one does. So I'm going to take this expression and substitute it right here into the first equation. 3x minus, I'm not going to use y, I'm going to use my expression 3x plus 2, and that equals negative 2. Remember, I took the y out and put the expression in its place. Now I solve. 3x minus 3x after I distribute minus 2 equals negative 2. I've distributed the negative to each of these, or the minus. Let's combine like terms. So we have 3x minus 3x, which is 0. So I have negative 2 equals negative 2. I think we've seen that before. Does negative 2 equal negative 2? Yes, it does. And since it is true, that means that we have infinite solutions. And if you remember from our previous lesson, if we have infinite solutions when we are finding the solution to a system, then these two lines are the same line. Let's do one more example. We want to pick the equation that has the variable solved. So we have this equation is solved for y, so we're going to substitute that expression into the second equation for y. So we have 6x plus 2. We're going to take out the y and substitute this expression in its place. Now we have one equation that is written in one variable, which is easy for us to solve. So we have 6x, and we're going to distribute the 2. 2 times negative 3 is negative 6, and 2 times 5 is 10. So we're distributing the 2 to each of these. And that equals 1. To continue solving, we need to combine like terms. 6x minus 6x is 0. So I have 10 is equal to 1. 10 is equal to 1 is not true. That means there's going to be no solution. And when there is no solution, we must have a set of parallel lines that do not intersect. Therefore, there is no solution. To review, you need one variable to be isolated, which means by itself, and then you replace that variable in the other equation with the new expression. Continue solving from there, and once you get your answer for one variable, be sure to plug it back in and find the other value of the variable so you have your ordered pair, which is your solution to your system. Also, remember, we can have special cases. If you have an example like 3 equals 3 that is true and not a variable remains, that will be many or infinite solutions. Or if you have a situation that is not true, like 3 equals 7, this would be no solution. Please continue by completing the reflection.